So today we learned how to turn repeating decimals to fractions using algebra. So notice for these two repeating decimals, we can't use that easy little pattern that we learned yesterday, where, for example, 0.8 repeating is 8/9, because look at these. See how we have digits right after the decimal that don't repeat before we get to a digit that does? So these are a little bit tougher. So we're going to set this up using algebra and the 4 steps we talked about today. Step 1. We are going to pick our variable n and set it equal to 0.268 repeating. N is going to be equal to this, but the fraction version of that. Step 2. Count how many repeated digits there are. In this case, there's only one repeated digit. And what we do is take 10 to the power of how many digits repeat. In this case, 1. So it's 10 to the first power, which is 10. Now that 10 tells us what to do for step 3. Because step 3 is multiply this whole equation by this number. And since we have 10, we're going to multiply this whole equation by 10. 10 times n, 10n. 0.268 repeating times 10, move the decimal over because we're multiplying by 10, we get 2.68 repeating. But, see how we've lined up all the digits? I would like to have a digit here so it lines up with this one too. And since we know that 8's repeating, we know the digit after this would also be an 8 because it goes on forever afterwards. So I'm going to fill in that 8 there so that way all the digits are lined up. Step 3. Actually, that was step 3. Step 4 is subtract and solve the equations. So I'm going to subtract these two equations and see what I get. I know that 10n's minus 1n leaves me with 9n's. And when I subtract these, because these are all 8's over here and all 8's over here, when I subtract these, I know they're going to get me zeros. 8 minus 8, 0, 8 minus 8, 0. All these, for all the infinite numbers 8's, they're just going to subtract to get 0, including this one. And so really what I'm subtracting is 2.68 minus 0.26. And that gives me 2.42. So by subtracting those two equations, I no longer have a repeating decimal anymore because they all subtracted out to zeros. And I'm left with a decimal that ends like 2.42. And now I can solve this. To get n, I'm going to divide both sides by 9. And the 9's undo each other. N drops down, equals drops down, and I'm going to leave this as a fraction because remember, we're trying to find a fraction. 2.42 over 9. And technically, that is a fraction, but we aren't allowed to have decimals in our fraction. So what I'm going to do is multiply the top and bottom by 100. And the reason I picked 100 is because I need to multiply this by something to move that decimal over. And I know if I multiply this by 100, it'll make the top number a whole number. 2.42 times 100 gets me 242. Over 9 times 100, 900. And look, I have a fraction that's all whole numbers now. But I can reduce that. I recognize right away that they're both even, so I know I can reduce the top and bottom by 2. So my final answer will be 121 over 450. And that fraction is the fraction that will equal 0.268 repeating. And if you're not sure, the cool thing about this is we can check our answer with a calculator. All we have to do is take 121, divide it by 450, and if we did this right, we should get 0.2688888888888888. And look, we do 0.268888888888, and that 9 was rounded up because the next digit was 8. So we know our answer is good. For the second example, now we have 3 digits repeating. Things get a little bit tougher, but the steps remain the same. We're still gonna, for our first step, set n equal to our repeating decimal. In this case, 0.2734. And remember, this repeating decimal is repeating 734 over and over and over again. 2734, 734, 734, 734. Step 2. I've got 3 repeating digits, so in my head I'm thinking 10 to the 3rd power this time, because 3 digits, 3rd power. 10 to the 3rd power is 1,000. So I'm going to be multiplying this equation by 1,000. N times 1,000 is 1,000n. If I multiply this by 1,000, I'll be moving the decimal over 3 places. So I'll end up with 273.4. But remember, I want digits to line up all the way through, and I've got 3 empty spaces right here. Luckily, I know that the 3 repeating digits are 734. So after this 734 are going to be another 734. And those 3 repeat forever and ever and ever. Step 4. Now we've got to subtract the 2 equations and solve for n. So I'm going to subtract these 2. 1,000 n's. Take away 1 n is 999 n's. And when I subtract these, look, 4 minus 4, 0. 3 minus 3, 0. 7 minus 7, 0. All of those repeating digits subtract out because they're all going to line up. And what I'm left with is 273.4 minus 0.2, which is 273.2. And again, because of the way we set this up and subtracted, we no longer have repeating digits. Now I can solve for n. Divide both sides by 999. The 999's undo each other. N drops down, equals drops down, and 273.2 over 999 is the fraction that decimal equals. But just like last time, we're not allowed to have decimals in our fraction. And I could multiply this by 10, but here's a quick trick. I know 0.2 times 5 will make a whole number. So I'm going to, instead of multiplying both the top and bottom by 10, I'm going to multiply the top and bottom by 5. And I'm going to save myself some time. Because if I multiply by 10 on the top and bottom, I know I'm going to have to reduce later. So I'm going to multiply the top and bottom by 5. And I'm going to get 1,366 for the top. And this times this, 4,995 on the bottom. And this is not reducible, and that is the fraction that equals my repeating decimal. If you're not sure, let's check it. 1,366 divided by 4,995. It should equal 0.2734, 734, 734, 734, and look, it does. 0.2734, 734, 73, and you get the picture. So that's the steps to changing any repeating decimal into a fraction.